Hello, my name is Miguel Madruga, and today I'm going to be doing the CAP 2 Theta Lactate assignment for Cal Baptist University Kinesiology 516. An overview of what we're going to be looking at today is the pathway, the Cori cycle, exercise intensity and training adaptations, lactic acid versus lactate, which there's a misconception out there that they often are the same thing, but there is a difference, and we're going to look over that a little bit today in how we use lactate metabolically. So we start off here by looking over the Cori cycle. So here we have a muscle in the liver, which is basically where the Cori cycle happens. In the muscle, we start off by there's a glucose that enters, glucose molecule, and it goes through glycolysis to turn into pyruvate. The difference from this to Cap 1 assignment is right now there's no oxygen present because the muscle is going through a high strenuous exercise, so it can't get into the Krebs cycle, so it needs to form energy a different way. So without no oxygen present, it turns into lactate, and then this lactate will go through the bloodstream, which is this little arrow right here, into our liver, where it goes through a process called glyconeogenesis. And basically, what that happens there is lactate gets turned back into pyruvate, and then this pyruvate would go then get turned back into glucose, and then again through the bloodstream transferred back to the muscle. It is very important to remember that this lactate only happens because there is no oxygen present in this action. If there were to be oxygen present, this pyruvate would turn into acetyl-CoA and go into the Krebs cycle and turn into ATP and all that those good things. How the pathway is affected by exercise intensity and training adaptations? Basically, how we went over in the previous picture is uh, there's a lack of oxygen because of the high intensity exercise. The human body can turn the pyruvate into acetyl-CoA, so it turns into lactate. So because of high intensity exercise, think about like a 10-meter sprint or a 100-meter sprint, or chasing after a baby who just fell into a pool, something like that, very quick. Our bodies lack oxygen in that time frame, and then our pyruvates turn into lactate. So if we were doing an exercise that's much slower, maybe a 2 mile run, there will be oxygen to keep producing pyruvates, and then our pyruvates would turn into acetyl-CoAs at a much slower pace. Where it's during high pace energies, our body will need lactate. Lactate gets into the liver, and then it gets reversed again into pyruvate and glucose, and then back into the muscle. It's a continuous cycle, as we learned the Cori cycle. When lactate levels build up faster than the liver can convert back to glucose, our body will start to give us signals. Me personally, when I used to be a soccer player back in college, preseason training was always very hard. And when my body was starting to get a little shivers, or felt a little nauseous, or sometimes even wanting to throw up, that's pretty much lactate formed, uh, built up in my body, and it's pretty much the body just saying like, "Hey, relax or slow down because you can't handle it right now." But training at a lactate threshold is also very beneficial. If we train at the highest level possible and push our bodies to that lactate threshold all the time, our VO2 max will improve a lot. And it'll just mean if today you were able to do 10 and you train at 10 very, very vigorously, tomorrow you'll be able to train at 15 and so on, so on. Our body is an amazing thing. It just keeps adapting. So just because our body signals one day at 10, hey, stop, stop, can't hold up anymore, doesn't mean tomorrow or the next day or next week it can't go more. You could always keep pushing your body in that lactate threshold to higher levels. Right now we'll look at lactate versus lactic acid and that misconception I talked about, how that they are the same thing. Uh, they're not. As we see here in the picture, lactate acid has a hydrogen ion to donate, and lactate does not, as we see right here in the hydrogen atom. Lactate could build up in the system, and lactic acid can't, and that basically is because of that hydrogen atom. When lactic acid is ready to get rid of it or donate it, it just does, and it won't build up. Lactate is produced during anaerobic glycolysis, where lactic acid releases that ion. Lactate used metabolically. Yes, like as we said, lactate is used during high intensity exercise to produce energy. So when we are doing the 100-meter runs or very quick, short burst, high intensity exercises, lactate is our fuel source, is what helps us out. Very important again to remember that lactate only happens because there is no oxygen there, and usually that means you're doing a high intensity exercise and you're having a hard time getting air into your muscles. If oxygen is present, lactate won't be needed, as glucose carries on to the citric acid cycle, as I mentioned before, or as we went over in our cap 1 assignment, and then it'll go on to create more ATP and so on. Okay, and are there any factors at work at the cellular level that could influence exercise sensation? Yeah, that could be like exercise, respiratory disease, making breathing harder, and then oxygen is already short enough when we're going through high intensity exercises, and respiratory disease will only make it worse. It will make it harder to get any type of oxygen in there, super hard. Cigarette smoking, it could reduce exercise capacity and make, like in point one with respiratory disease, make our breathing harder, make it harder to hold our VO2 max levels in there or get high VO2 max levels. Okay, and that is my works cited page. Thank you very much. That is my Cap 2 assignment.